Okay, section 3.4 is one of the more complicated sections in chapter 3, so you're going to want to pay attention. It's talking about supplements and complements, which you may or may not have heard the terminology in the past. But basically, if two angles are supplementary, then they add up to 180 degrees, or they add up to a straight angle. And if two angles are complementary, they add up to 90 degrees, or they add up to a right angle. And I want to introduce something right now that is true with all definitions, and that is that it works in both directions. This is what's called biconditional. So when I have something that's biconditional, I can use the if-then symbol, that arrow, where the arrow goes in both directions. And what that means is, for example, let's start with a simple example. If I have a right angle, then it's 90 degrees. Or if I have an angle that's 90 degrees, then it's a right angle. It works in both directions. Okay, so similarly, what we have up here is that if I have supplementary angles, then they add up to 180 degrees. Or if I have two angles that add up to 180 degrees, they are supplementary to each other. Okay, so it works in both directions. And that's true about all definitions. They are biconditional. All right, so there's some word problems. I know everyone's favorite is word problems on top here. And the way I'm going to do this is basically I'm going to draw a little diagram here. If I have an angle, and let's call the angle X, and here's a perpendicular line here. And so the complement to X is the angle that makes up the 90-degree angle there, is just going to be 90 degrees minus X. That's going to be the complement to this original angle X. And the supplement to angle X is the angle that makes up the rest of the 180 degree. That's the supplement. And that angle is represented by 180 degrees minus the original angle X. So whenever I'm doing one of these word problems, in 1, 2, or 3 here, when I see the term angle, I'm going to use X. When I see 90, and when I see complement, I'm going to use 90 minus X. And when I see the word supplement, I'm going to use 180 degrees minus X. So here's what I mean by that. Okay, so when you're doing these word problems, the best way I've figured out over the years to do these problems is to translate these very directly. So if I say that the measure of the angle, that's X, is, that's an equal sign, okay, 30 less than the supplement. Well, the supplement is going to be 180 degrees minus X, that's the supplement. And if I say 30 less than that, it's just going to be minus 30. And then I can solve this thing for X. I go ahead and do all the work here. I get X is equal to 75. And what that represents is that represents the original angle. And you got to make sure that you are solving for what it's asking for. In other words, it says find its measure, which is representing the measure of the angle. And so we did find the measure of the angle. Let's try another one just for kicks. So the measure of the supplement of an angle, so 180 minus X, is, let's use blue again, 60 less than 3 times the measure of the complement. So let's do 3 times the measure of the complement. 3 times The measure of the complement, remember, is 90 minus x. And then 60 less than that is going to be minus 60. I solved this thing for x. X ends up being 15, I believe. Okay, you can do the algebra on that. And it says find the measure of the angle. Okay, so we're not really doing anything tricky there. But if I had said instead, find the measure of like the complement, find the measure of the complement, then what I would have done with the 15, since that's the angle, is taken 90 and subtracted 15. Okay, and gotten 75 out of that. That would be the complement, if I had asked for the complement. Okay, hopefully that makes sense. Let's go ahead now and let's talk about the couple of theorems here that we're going to use for the proofs that have to do with complements and supplements. So for this one here, it says that you have a right angle here, right angle here. So I have a right angle here and a right angle here, kind of overlapping right angles. ORL is 60 degrees. This middle angle is 60 degrees. And so find the measure of these two angles right there and there. Well, hopefully you can recognize that they both have to be 30 and they both have to be the same. Okay, so the theorem that comes out of this is that if angles are complementary, so they add up to the same angle. Can you see that this angle here and this angle here are complementary to this same angle, this middle angle? Then those angles are congruent. Or I can write this as complements of same angle are congruent. Okay, and that's what I would do in a proof. I would write that as complements of the same angle are congruent. And this works for supplements also. Okay, so supplements of the same angle are congruent. Related to this, okay, F is complementary to G. So let's say this was 30 and this is 60. And H is complementary to J, so this is where G and J are congruent to each other. So these are both 60. And so this must be 30 also, since they're complementary. And so if angles are complementary to congruent angles, then they are congruent. So in this case here, these angles were congruent to each other. So, and these are comp, and these are comp, so therefore these have to be congruent to each other. They're both going to be 30. So if angles are complementary to congruent angles, then they are congruent, or if angles are supplementary to congruent angles, then they are congruent. Okay, so those are related to each other. These theorems are related to each other. So I could write this as comps of congruent angles are congruent. Okay, comps of the same angles are congruent, that's this one, and then comps of congruent angles are congruent, that's that one. Let's work it out in a proof. So, this first proof here, I know that this is perpendicular, so I know that this is congruent, or so these are right angles, which means that these are complementary to each other, and these are complementary to each other, right? And ABP, excuse me, this one is congruent to DBW, which is this one. And we're trying to prove that this one is congruent to this one. And hopefully you can see that they're complementary to two congruent angles, and so therefore they are congruent to each other. So let's set it up. So step 1. AC is perpendicular to BD. It's given. Step 2, I know I get if perpendicular then right angles, so angle ABD and angle DBC are right angles. If perpendicular, then I have right angles. That's going to be a very popular reason, by the way. And I know that because of that, I could say they're congruent to each other, but that's not really what I need here. I really need for these two angles to be complementary to each other. So I need angle ABP is comp to angle DBP, excuse me. And I also know that these two angles are complementary to each other. So angle DBW is complementary to angle WBC. So we're going to use the biconditional thing and go in reverse. So basically we know that if you have right angles, if two angles make up right angles, then you end up with complementary angles. Okay, notice that the direction that I did this in is because if I have right angles, then I have complementary angles. So if I have right angles, then I have complementary angles. Step 4, I can go ahead and throw in my given here. Angle ABP is congruent to angle DBW. That's just given. And then in step 5, I can now say that angle PBD is congruent to angle WBC because here's the magic step. Complements of congruent angles, here's my congruent angles, right, are congruent to each other. And there's my proof using the theorems that we just learned. All right, let's go to the back side and let's try a couple more proofs. Okay, moving on to the back side here, looking at proof number 4. And it's one of the longer proofs, so bear with me here. The givens are first, you have perpendicular, two perpendiculars, which then gives me right angles. Also, ABC is congruent to FEG, which is this angle right there. So I know that this angle's got to be congruent to this angle, right? Because they're comps of congruent angles. AF bisects DE. So AF chops into congruent segments. It chops BC. So that means that, or BE, which means that this is congruent to this. And which triangles am I trying to prove here? It looks like I'm trying to prove that this is congruent to this. Let's get that on there. So triangle BCD is, let's get the white lettering. It looks like it's going to be E matches up with a B. Looks like G and D. Okay, and of course I have vertical angles here at the center. And so by, looks like angle, side, angle, I'm going to prove the triangles congruent to each other. Alright, and again, that's how you should start the proof, kind of sketching out your approach, and then going ahead and writing your proofs. And you really should not write anything down until you do that, until you map it out a little bit. So, the givens are AB is perpendicular to BE, and FE is perpendicular to BE. Step 1, given, please do number your steps. I know that angle ABD and angle FED are right angles. If perpendicular, then right angles. Step 3, I know that because of these right angles, I know that angle ABC is complementary to angle CBD. I also know that FEG is comp to angle DEG. If I have right angles, if two angles make up a right angle, then they are complementary. And angle is given an angle ABC congruent to angle FEG. Okay, and notice when I use that, I am using that because these are steps that are grouped together, and those two steps are going to give me this next step here. That's why I'm using the given in this particular placement. Okay, I'm trying to group things together if I can. So angle CBD is congruent to angle DEG, right? Because these are congruent to each other, because I know that these are congruent. So step 5 is going to be comps of congruent angles are congruent. Step 6, I know that AF bisects BE. It chops that in half, which means that BD is congruent to DE. If I have a bisector, then I end up with 2 congruent segments. Step 8, I'm almost done here. I got my vertical angles to put in there. So angle CDB is congruent to angle EDG. Vertical angles are congruent. All right, let's finish it off. Triangle BCD congruent to triangle EGD. Step 9, angle, side, angle. Okay, let's find the steps. Looks like it's from step 5, step 7, and step 8. Okay, so it's 5, 7, and 8. All right, 9-step proof. We almost got to 10 steps there. That was pretty exciting. Okay, let's jump down to the last proof. And so this last proof is a supplementary proof. That's why I put this on here. So it says that WOC is congruent to IJL is congruent, which hopefully means that you can see that these two have to be congruent because they're supplementary to the congruent angles. Since these are straight angles here, this angle and this angle are straight angles. And then CJ is, let's get a different color here. CJ is congruent to OI, and WO is congruent to LJ. And I'm trying to prove that these triangles right here, OWI is congruent to this one right here. And perhaps you can see that these triangles are going to be proven by side, angle, side. Side, angle, side. Okay, step 1, and this is important. I can say, I'm going to allow you to say that angle COW is supplementary to angle WOI, and angle LJI is supplementary to angle CJL. And that's just going to be because if I have straight angles, okay, I'm going to assume straight angles. Don't need to write a step there. Then I'm going to have angles that are sup to each other. And then my given here is that this angle is congruent to that angle that's given. And I can actually put all that in the same thing, if maybe. Let's not do that. Let's put the angle WOC congruent to angle IJL, which means that angle WOI is congruent to angle LJC. get all these letters right, because supps of congruent angles are congruent. And then now I can go ahead and let's use these two in step 4. That'll be given. And that finishes off the pieces that I need to say that OWI is congruent to angle JLC. Step 5, side, angle side from steps 3 and 4. Okay, I know that was a lot of material in this section. Hopefully you're okay with it. I'll give you a chance to give it a try, so good luck.